So good morning. So in today's class we are going to see about the economic speed of CLM engine. So this CLM engine is an opposed piston two-stroke engine. So where two pistons will act against each other and you can get the power in twice. So this is a economic speed engine. So where you can measure the economical speed by maintaining constant load on that machine. So when you go for the procedure of this CLM engine, so we can say that first you have to measure the circumference of the brake drum and then the circumference of the rope. So if you find the radius of this, so where 2 pi r is equal to the circumference, so you can find the capital R as the radius of the brake drum and small r as the radius of the rope. So and if you add these two, you will get the effective radius. So if you find the effective radius, you can find the maximum load of the engine. So if you find the maximum load of the engine, you can keep that 75% of the maximum load as the constant load. So if you go for 100%, you will get more vibrations and all. So we are going to keep 75% of the load as the constant load, and then we have to vary the speed. So from the rated speed, you have to take from the rated speed. So by an interval of 100 rpm, you have to reduce that further. So even you can reduce up to 900 rpm. So from 1500 to 900 rpm, you have to reduce in 100 intervals. So when you reduce that, so you have to maintain the load as constant and you have to vary the speed. So for each and every speed, you have to measure 25 cc of fuel consumption, and in this CLM engine you can measure the brake power, you can measure the total fuel consumption and the specific fuel consumption. So if you measure all this, so initially we will find the value of the maximum load, and then you have to find brake power, then total fuel consumption in kilogram per hour, that is the amount of fuel consumed per unit time is nothing but the total fuel consumption, and the specific fuel consumption is the amount of fuel consumed per kilogram, that is per kilowatt hour. So this kilowatt hour is, you can see, is energy constant, it is nothing but 3600 joule. So you have to measure all this. So if you draw the specific fuel consumption along, if you plot a graph, you have to draw the specific fuel consumption along the y-axis and the speed or the load along the x-axis. So you can find the value of the economical speed. So you will get a U-shaped curve, and the bottommost point will give you the economical speed, and similarly you will find the value of the specific fuel consumption and the speed. Okay, so this is the basic procedure involved in this CLM engine. Okay, so now we can move on to the engine and how this engine also works, and then we can move on to the calculation part. So this engine is the CLM engine. It is a two-stroke opposed piston engine. So where you can see the two piston which is acting against each other inside this engine cylinder, and when you want to get the speed, it is doubled. Suppose if it is 750 rpm on one, then the other will give you 750. So if you add these two, you will get 1500 rpm. And now we are going to see what are the readings that you have to measure in this CLM engine to find the economic speed of this engine. So first you can see this is the brake drum, and you are going to measure the circumference of this brake drum and then the circumference of the rope. So if you find these two, and if you find the radius of these two, you will get the effective radius. So first we are going to find the circumference of the brake drum. Now it is around 88 centimeter, and then you are going to find the circumference of the rope, which is around 7 centimeter. So if you find these two, that is 2 pi r is equal to, capital R is 2 pi r, that is equal to 88 centimeter, and 2 pi small r is equal to 7 centimeter. And if you measure these two, so you have to find the value of capital R and small r, and if you add these two, you will get the effective radius. So with the help of that, you can find the value of the maximum load. So if you find the maximum load, so you can go for 75% of the maximum load as kept as constant. So here in this engine, the 75% of the maximum load is around 21. So 21 kilogram force kgf. So that 21 kgf load is kept as constant. So if you keep that as constant, and you have to start the engine. So initially you have to start the engine. So with the help of this you have to rotate and you have to start the engine. So you can move on like this and you can start the engine. So then you should know what is the speed at which this engine runs. So it is given in the specification. Here the rated speed, you can see the rated speed. That rated speed is 1500 rpm. So initially, so you have to make this engine to run at 1500 rpm, and that can be measured with the help of this tachometer. So this is a device which is used to measure the speed of the engine, whatever may be the speed which is in revolutions per minute. So you can measure the speed. Then you have you have to ensure that you are varying the speed by maintaining the load constant. So you can keep here that by varying this you can keep the load constant, and by varying this lever, so you can make the speed constant, that is varying speed from 1500 to 900 rpm. So at 100 intervals, so 1500, 1400, 300, then 1200, then 1100 up to 900 rpm. So you can vary the speed. And if you want to cut off the fuel is cut off with the help of this lever. So then when you start the engine, so you can ensure that the speed is 1500 rpm, and for each and every speed, so you have to measure the fuel, that is how much of fuel is consumed. For example, here we take the fuel consumption for 25 cc. So for 25 cc of fuel consumption, how much of time is taken? So you have to measure that. So that the fuel consumption can be measured with the help of the tank from the fuel. So this is the fuel tank. So from this fuel tank, the fuel is supplied, and through this tube it is supplied to the engine, and this is for the measurement 25 cc of fuel consumption. And you can see the line. So here, from here to this place, so the total amount of fuel that is consumed by the engine will be 25 cc. So from that 25 cc of fuel consumption, you can measure the parameters. So what are the parameters? Total fuel consumption, specific fuel consumption, and brake power. And here you can see, if you want to, if now this is in closed position, and if you open this, so you can open this. If you open this, so the fuel is supplied to both the engine as well as to the beaker where you have going to measure this 25 cc of fuel consumption. Suppose if you, so after running this engine, so if you ensure that the speed is 1500 rpm, so you can cut off this fuel supply, and now the fuel will go from this beaker, that is you can measure this 25 cc of fuel consumption. So thereby you can measure the value of the specific fuel consumption, and from that you can find the best speed where the amount of fuel that is consumed is less. So now you are going to start the engine. So down, so the speed increases. stop this stopwatch, and we have to once again we have to release this lever or this knob, so that we can ensure that the fuel moves from the fuel tank to the engine. We have to off it, so by using this lever, this lever is nothing but the fuel cut-off lever, and now the engine is stopped. So initially, so what we did is we have started the engine, and then we ensured that the speed is 1500 or not. Suppose if the load is given to this engine, so we have to maintain the load as constant. So for that, finding the maximum load, so we went for effective radius, that is we have measured the radius of the brake drum, and also we have measured the radius of the rope. So we find the value of capital R and small r, and if you add that, you will get the effective radius. From that we found the maximum load. From maximum load, 75% of the load is taken for maintaining the load as constant. So for 75% of the load, we have varied the speed. With the help of this speed lever, we have varied the speed. So from 1500 to 900 rpm at an interval of 100. So then for each and every speed, so we have measured the fuel consumption. That is 25 cc of fuel consumption is considered, and for that 25 cc of fuel consumption we have measured the time. So how long it takes to consume that 25 cc of fuel by this engine. So we have measured that one also. So from all this, so we are going to find the value of brake power, total fuel consumption, specific fuel consumption. So initially we found the maximum load also. So these are the parameters for the measurement of the economic speed of the engine. So after that we are going to draw a graph between this specific fuel consumption and the speed. So for you have various speed from 1500 to 900. So that has to be initially given in the graph in x-axis, and this specific fuel consumption has to be given in y-axis. So when you draw a graph between these two, so you will get a U-shaped curve. The lowermost point will give you the economic speed and the best specific fuel, that is specific fuel consumption. So in terms of kilogram per kilowatt hour, and speed in terms of revolutions per minute. So this is about the engine part, and we can also see the experimental, that is calculation part, in the next session. So far we have seen the engine part in economic speed test on CLM engine, that is what are the data that we have to measure in the engine. So now we are going to see the calculation part. So in case of calculation part, so first thing is we went for the maximum load, so then the brake power, and then the total fuel consumption and the specific fuel consumption. So initially for all this we have measured the circumference of the flywheel and the circumference of the rope. The circumference of the flywheel, that is 2 pi capital R is equal to, so is measured and the value is taken as 88 centimeter, and for the circumference of the rope 2 pi small r is equal to 7 centimeter. From that we have found the value of capital R and small r. If you add these two, that is capital R and small r, we will get the value of the effective radius, that is R effective. So from R effective we found the maximum load. From that maximum load, the 75% of the maximum load is taken, and that load is kept as constant, and we have varied the speed in the engine, and for each and every speed we have measured the fuel consumption. So that is the procedure we have adapted in the engine part. So now we are going to calculate the value of all those. So that is what is the value of brake power, what is the value of total fuel consumption and specific fuel consumption, by forming a tabulation. So with the help of that tabulation, so we will find all these datas, and then we will draw a graph to find the economic speed. So the speed at which the fuel consumption is very less. The fuel consumption here refers to specific fuel consumption. So when the specific fuel consumption is very less, at what speed? Then that speed is taken as, they are considered as the economical speed of the given CLM engine. So now, so you can see that the circumference of the brake drum, not the flywheel, it is the circumference of the brake drum. So that is 2 pi r, so given as capital R, which is equal to 88 centimeter. So from that you can find the value of R. So that is, R is around 14.08 centimeter. And then circumference of the rope, which is given in the rope brake dynamometer. So that circumference has to be measured, and that small r, that is radius of the rope, is taken as small r. So 2 pi r is equal to 7 centimeter. From that, the small r is equal to 1.149 centimeter. So if you add these two, that is capital R and small r, you will get the value of the effective radius. The value of effective radius is around 15.27 centimeter. This effective radius is used in the formula to determine this maximum load. So from that maximum load, you will get the value of brake power, and then TFC, and then SFC, that is total fuel consumption, and specific fuel consumption can be found out. Then after this, so the tabulation has to be created. From the tabulation, so you can find each and every data that is given in the tabulation. So this is the tabulation part. You can see here, so the load in the engine is kept as constant. So it is around 21 kg. So we are going to convert this load into Newton. So if you multiply this by 9.81, so you will get the value of this kgf in terms of Newton, that is 206.01. So for all the 5 set of readings, so the load is kept as constant, and we have varied the speed from 1500 to 1100. Even this can be extended up to 900 rpm if you are not getting the economic speed. Okay, so now the speed for 1500, so we are going to find the value of brake power. Then we are going to find the time for either VCC or otherwise XCC of fuel consumption. VCC or XCC of fuel consumption. So we will find all this. Then we will find the value of specific fuel consumption, and total fuel consumption, and specific fuel consumption. So now we can go to the calculation part. So for example, if you take any of the readings, any set of the readings, that is second reading, so you can take, so here maximum load, so that is W max is equal to BHP is the rated brake horsepower that is given in the engine. So that is given in the specification. So BHP is around 9 into 4500 divided by 2 pi, n is the rated speed. So the rated speed is 1500 into R effective. So that is 15.27 into 10 power minus 2. So we have measured the effective radius as 15.27 centimeter. So you are going to convert this into meter. So into divided by 100, that is into 10 power minus 2. You will get the value as maximum load as 28.14 kg. So this 28.14 kg is taken as the maximum load. For this maximum load, so from this maximum load, you will keep 75% of the maximum load is considered for this constant load. Okay, so 28.14 into 0.75, you will get around 21 kg. So that is converted into this 206.01 Newton. Okay, so now we move on to this brake power. So this is the formula for brake power. So that is 2 pi n into W into R effective divided by 60 into 1000. So 2 into pi into that W is taken as the load, that is 206.01 into R effective, that n is the speed. So we have assumed for this one, we have assumed for the second set of calculation, the speed is 1400, and then So the effective radius is 15.27 into 10 power minus 2 divided by 60 into 1000. So the brake power we got, that is the power which is available at the shaft, is equal to 4.61 kilowatt. So this brake power, so we are going to use this brake power for finding the specific fuel consumption, and before that we have to find for total fuel consumption. So that is TFC, which is equal to this XCC into 3600 into specific gravity of the oil or the fuel that is used. So for us diesel it is 0.833 divided by T, the time taken. So the time taken here is, for that XCC of fuel consumption is 40 seconds. So that 40 into 1000. So this TFC will be equal to 25 is the time taken into 3600 into specific gravity of the fuel divided by 40 into this 1000, that is equal to 1.874 kilogram per hour. So this XCC, so the XCC is this 25 cc we have considered. So that is 25 into 3600 into 0.833 divided by, this is the value of P, that is time taken for the consumption of this 25 cc of fuel, into 1000. So it is TFC is equal to 1.874 kilogram per hour. So that is the unit for this total. So you can even define the total fuel consumption as the amount of fuel. So kilogram refers to the amount, that is the amount of fuel consumed per hour is can be defined as total fuel consumption. And when you go for specific fuel consumption, it is given by the formula TFC divided by BP is nothing but brake power. So the unit for brake power is kilowatt and the unit for this one is kilogram per hour. So if you go for specific fuel consumption, the unit is kilogram per kilowatt hour. So TFC we know the value is 1.874 divided by the value of brake power that we have found here as 4.61 kilowatt. So 4.61. So SFC is equal to 0.406 kilogram per kilowatt hour. So that is kilogram per hour for total fuel consumption and kilowatt for brake power. So now we have found out the value of brake power, then total fuel consumption and specific fuel consumption. So now you are going to find the economical speed. So for that you have to draw the graph, and before that, so all these 5 set of readings has to be completed. So using the same calculation, and from that you are going to draw the graph. So from that graph, so you can see that so engine speed is taken as taken in the x-axis and the specific fuel consumption is taken in the y-axis. So if you plot a graph for this specific fuel consumption and the engine speed, so if you plot a graph for this, so that is you can take this as 1100, 1200, 1300 and so on up to 1500. So and you can mark the specific fuel consumption here. So you will get a U-shaped curve. You will get a U-shaped curve. So that is the lowermost point. It refers to, so this point is the SFC and this point is the engine speed. So from this you can find the lowermost, that is the fuel that is consumed at this place is the economical fuel, and the speed, the respective speed is the economic speed. So for that is the fuel here that is consumed is very less at this point. So at this speed, so that is this speed is considered to be the economic speed of the given CLM engine. So the objective is to determine the value of the economical speed of the engine. So that has been found out with the help of this graph, where engine speed is taken in the x-axis and the specific fuel consumption taken in the y-axis. So you will get a U-shaped curve, and the lowermost point refers to the fuel consumption, that is specific fuel consumption, and its respective speed is taken as the economical speed. So in this economic speed test, so we determine the speed that is at which the fuel consumption is very less. So that is specific fuel consumption is very less. So when you go for an overall view, that is from the experimental part to the conclusion part, that is calculation part and the conclusion part. So we can see that we have measured, we have maintained the speed as we have varied the speed, and we have maintained the load as constant, and that load, that is 75% of the maximum load, and we have varied the speed from 1500 to 1100, and even you can vary up to 900 rpm if you are not getting the economic speed. And when you go below that, you will see some vibrations in the engine. So it is advisable to go up to 900 rpm, so in case of this CLM engine. And apart from that, so when you go for the calculation part, so you have to find the maximum load, then total fuel brake power, total fuel consumption, specific fuel consumption, and then you have to draw a graph to determine the economic speed of the engine. So this economic speed, so is we are determining the value of economic speed. So as we have, all of us have vehicles, so we can decide at which speed we can run the engine, so you will get a better fuel consumption. So that can be that speed can be called as economical speed. So with this the experiment of this economical speed so comes to an end.